Wendy.
Okay, and a hush fell over the room.
And the hush.
Okay, let's try that one more time. This mic must not be on. Testing. And a hush fell over the room.
And the hush.
Because if a hush doesn't fall over the room, I transform, and it's not pretty. Okay.
Oh, I see the green.
Did we hear that well enough? Testing. All right. So on this blank board behind me, let's jump to this right here. I don't know why that bothers me so much. It just
Elizabeth.
does.
No, don't do this. Yes, do it.
Okay, 725 divided by 4. Please check it with multiplication. Finished. Check it with multiplication if you've gotten finished. I think we've got to at least get started. We've done this way too much for us not to know how to start. Don't wait for me to come look at your board to start. Alright, you're not going to ask how many 4s can I get out of 72. You don't have to start that big. What are you going to ask, Martin?
I'm gonna ask if you can subtract 4 from 7.
Okay, how many 4s can I get out of 7? Simple question. Okay, just 1. So 4 times 1 is 4. We subtract that and get 3 and bring this down. Now, a fact family should come to mind. How many 4s can I get out of 32? Yeah. 8. Okay. 4 times 8 is 32. Bring the next digit down and it's a 5. We can ignore that 0 when it's on that side of the number. How many 4s can we get out of 5?
1.
Just 1. Okay. And so the nice thing about long division, might not be your favorite, but if there's leftovers, there's a place for them. You know, there's something you can do with that right there. So then if we check it, 181 times 4 plus the remainder. Okay. Will give us 725, which is what we were looking for.
I agree.
Okay, all right, there we go. Okay. I could see it every time I raise my hand. All right, so what if I asked you to do this? Write this number on your board, 9,000,000 234,923. Okay. Okay, one more time, look at this number because I think some of us still get intimidated, not sure, we're not sure how to say or write these numbers sometimes. Look at where the commas are. 9,234,000. Everybody can read 234 without any trouble. 234,923. So you only really have to worry about reading those numbers in blocks of 3. Okay? Of course, there's not 3 digits there on, right there. Just 1. And those 3 go together, those 3 go together. Anyway, let's round this to the nearest million. So if you saw that dash under that digit, you would know to round to that place. So round it to the nearest million. What would you do? Walk us through this. What would we do? Brandon, what would we do first?
We look at the 2 and see that we should make it the rest of the numbers 0 because 9 won't be able to go up.
9 doesn't go up, so we know we keep the 9. And from that arrow over, they're all zeros. It's a good idea to count them because that's a lot of zeros just to make sure. So, 3 and 3 is 6, so 6 zeros. Okay, and that just simply rounds to 9 million. Okay. All right, so let's go ahead and clear our boards. We'll jump in. So you can push your board to the side for right now. Okay. Go ahead and just put the top on your marker. We'll get it in just a second. This is lesson 32. I think we go up to the early 40s or the late 30s in this module. So we're in the second half. We're getting close to the end. There are still several important things to do. But we are on the second half of this module. So in lesson 32, okay, I guess this is a good time, and our button is still in place. It's what you've all been waiting for. I could feel the anticipation building this week. We've been adding fractions, and finally, we get to turn a corner. We get to reverse the operation, and it says, I can subtract a fraction from a mixed number.
Dun, dun, dun.
Okay, so see, mood music, we need background music sometimes in our lives. It just sets the tone of things. Okay, some people think because of this lesson we need this scary background music. I don't think so. I think you're going to show subtraction who's boss today. And I think you're going to storm the castle, so to speak, and it's going to be no problem. Okay? All right. So, let's jump in. It does tell us that we're subtracting a fraction from a mixed number. So, just like with addition, we started with a mixed number and just a fraction. Okay? That's how we're starting with subtraction. So, let me pull that up. Okay. Now, I will say this, our book, and we may see these words in our problem set where they are showing different ways and different strategies. Like yesterday, our book had several different, remember I told you to cross off the number line and don't worry about some of those things. I'm not showing you every single strategy or method in the book. Miss Megan and I believe, talked a long time ago and just decided sometimes it's best to just pick one way and stick with that way so there's less confusion. Okay, it doesn't mean other ways are wrong. It just we're just trying to make something that could be more difficult or confusing a little less confusing. So if I put this up here on the board, 4 and 11/12 minus 3/12. Okay. All right, look at that one. Look at that particular problem. And think, what do you think you would do to find the answer? Okay? What do you think you would do to find the answer? Because there may come a time, even after we've learned this, way on down the line, where it's been a long time since we've done this, and you might have forgotten a lot, and now you've got to do it again, you know. What would you do? Knowing everything you already know, how do you think it's possible to solve this? Charlotte, what would you do? 11 minus 3. So are you saying 11/12 minus 3/12? Like you're going to subtract the fraction pieces? Okay. So Charlotte says subtract the fraction pieces. Anybody have something different you either want to add or, yeah?
I would like to add on to what Charlotte said because, like, after you add the 11/12 minus the 3/12, you would bring the 4 over, and you would put which is kind of.
So you're saying the whole number part's probably going to stay the same? Just bring it over? Okay. Anybody want to add? That's what you're going to say? Same thing? Okay, same. Any other thoughts? Okay. Do y'all remember yesterday how you had to kind of be very watchful? This is what I mean. You would add up your mixed numbers, and only if in the answer you had an improper fraction mixed in with that mixed number, did you have to do that extra step? But if you were watching carefully and you saw, oh, this is not an improper fraction, I can leave it, you had to be watchful for that. You've got to be watchful when it comes to adding, subtracting fractions. Okay? Can we subtract 3/12 from 11/12 without any trouble? Do we have enough 12s to take this away? Yeah, we have plenty of 12s. Because we have plenty of 12s already, we don't have to disturb the 4. Okay? We don't have to change this. We can do exactly what you just said. So, the 4 would come on over. Now, this is not true every single time. This is why I want you to be watchful, okay? But because we can do this subtraction easily, what is 11 take away 3?
8.
Okay, it's 8. So we are left with 8/12. We subtracted this piece right here and this piece right here. We took the 3 away from the 11. Yes?
What if it were like 4 and 3/12 minus 11?
We're fixing to look at that. That's a great question. I'm glad you asked it. Okay? In other words, what Will is asking, I think this is what you're asking, is what if this was the smaller number and this was the larger number over here? And I'm going to show you exactly what to do. Okay? But y'all see how easy it is if you catch that you can easily subtract these two. That's all you do. Okay? If it's not that way, well, we could use this very problem since you asked it that way. Let's do that. Okay, let's just erase everything. And we'll rewrite it. 4 and reverse it this time. 3/12 minus 11/12. Okay, now look at that closely. Is this going to be the same situation? Okay. You can't subtract 11 from 3. You can't subtract what you don't have. But this is the thing. Do we really only have 3/12 sitting here?
No.
Okay.
We got that.
Okay. What do you think you would do?
You turn 4 and 3/12 into a mixed number. I mean, an improper fraction, and then you subtract it, and then turn it back into a mixed number.
Okay. Gonna add. Okay. So to solve this problem, you would. Do you know what I think I'm fixing to do here? I am going to ask that we not get activity today. Okay. I'm also going to give you a really large packet of work to do during Aspire. Okay. I'm also going to start saying. I'm also going to start saying things. What did you say, Miss Danielle?
No, you don't. Yeah. Miss Danielle's not racing.
I know. I'm teasing.
Are you
Okay.
about
Okay.
that?
I need you to listen right now. I need you to listen right now. I'm also going to ask that they no longer have pizza in the.
Thank you.
Thank
you.
And I'm going to ask that it always be broccoli. No more recess. Ignore Caleb.
Okay.
No more extra recess in the afternoon.
No more make
That's
it.
gonna be extra time.
I can get my recess.
Listen.
Yes,
Okay.
never a weekend.
How are you feeling right now?
Mad.
What?
Mad.
Mad?
I'm mad.
Okay. You're feeling mad. You're not mad. I knew the broccoli thing might brighten your day, but okay. Here we go.
Yeah. No. Wait for
I just said all that to get you to remember to use mad here. Okay. All right. I was trying to make you mad, but it becomes this big dramatic event. So never mind.
We get to make our own one now. No
Okay.
school,
Nope.
Gym all
Yep.
day. Football all day.
Here it comes. Really getting mad.
Hulk is coming.
Not kidding anymore.
Hulk is coming.
Okay. All right. Go ahead.
School every single day, even on the
Okay.
weekend. No.
We're done with all that. Okay. So what we're going to do is exactly what Will just said, and we're going to change this into an improper fraction, because when you do that, you really see how many twelfths we actually have. Okay, so on your board right now, take 4 3/12 and change it into an improper fraction. All right, help me figure out what that's going to be. Oh, man. Just pulled out the 12ths again. Yeah, it's time we know these a little better. What two numbers are we going to have to multiply? The 12 and the 4. No number bonds here. We're doing math. We're multiplying or adding the numerator into it, and then we're putting it over the denominator. What is 12 times 4?
48.
Okay, this is, that would be you. That's him. Okay.
Ishmael?
Go ahead.
48.
48. Plus 3 more would be 51. So we've got 51 twelfths. Now, would you say we've got plenty of twelfths at this point?
Yeah, definitely.
We definitely have enough twelfths to subtract 11. Okay? So, y'all can give me your eyes again, okay? This right here, even though it looks like all I've got is 3 and I've got to subtract 11, that whole 4 is made up of twelfths. Every time there's a 1 whole there, there's 12 twelfths. We've got 12 twelfths 4 times, plus this extra 3. We've got 51 of them, and now we're going to subtract 11. Okay, so on your board, subtract 51. Excuse me, let me say it the right way. Let's subtract 11 twelfths from 51 twelfths. Go ahead and do that. You might have to come over here and do this. It's okay to do this. I have to do it all the time when I do math. How many twelfths do we wind up with?
40 twelfths.
40 twelfths. And we're done. Yes?
No.
No, we're not. 40 twelfths is an improper fraction, and so we're not leaving that as the answer. Now, what do we pull out? What method, what tool do we pull out now? Yeah.
Number bond.
Number bond. So take that, and we're getting faster at this, guys. You could, how many times can I get 12 twelfths out of there? You can do it a little faster. What is the most groups of 12 I can get out of there? Yeah.
3.
3. What is 3 times 12?
36.
I'm going to put them all together. You don't have to do that. You could do 12 twelfths, 12 twelfths, 12 twelfths. I'm just lumping them together, right? Okay. And then when I take away 36, how many are left? Yeah. 4. So this is equal to 3. And then we have 4 twelfths left over. So our final answer is 3 and 4 twelfths. That is a great 4th grade answer.
Yeah.
What would the 5th grade answer be? Don't yell it out. What would the 5th grade answer be? This is great. This is perfect. If you land here, that's what I want. But if you can start seeing the 5th grade answer, you're going to help yourself. What do you think?
3 and 1/3.
3 and 1 what?
3rd.
3 and 1/3. Yep. Because if you divide both of these by 4, you get 1/3. Good. Okay. All right. So that's what we're doing. We're going to work a few of these together. Question? Hold on just a second. Let me put this problem on the board so we can get started. Okay. Brand new problem. If you saw this, what you would need to do first, you know how a lot of times I'll ask you, what's the first step? I don't want you to tell me, oh, do math or do that. I want you to tell me that you're going to stop and you're going to look closely. Because you're looking to see, can I subtract this without changing anything? And if you can't, then you pick one of those things. What thing are we going to pick? What are we going to do first? We've stopped. We've looked at it. That thing just.
What happened?
Whose pencil did that come off of? Because that thing just ricocheted and bounced.
What was it? A groupie?
Just a groupie. All right. Never mind. All right. What is our first step after looking at this closely? What is our second step? I guess I should say it that way. Mason?
Our first step is to turn the big number to the top.
What do we use to do that? Is that not good enough? What do I use? Mad. You can't laugh and be mad at y'all at the same time.
Why not?
Okay. Alright, so you're going to, now that we see we can't just quickly subtract, we're going to have to use math first. Okay? So go ahead and do that.
Already got the whole thing done.
Okay, don't let that take so long. Get started. Okay. I was fixing to do something. I can't remember. Okay. This is okay for me. Give me something.
That's not something you laugh at, Reagan.
Alright, we're quietly working on here. You got an answer, just sit tight for just a second. So really what we're doing today is just a kind of a new mixture of some of the same things we've been doing for several days. We're using using MAD. We've done that a bunch. We're subtracting. We've done that a bunch. Okay. All right, when you use MAD, what does that mixed number become? What is the improper fraction it turns into? Valerie, what do we get? I'm sorry, I wasn't looking. What? 15 fifths. Don't forget to add.
I forget that a lot too.
Well, it's an easy mistake. So 15. Give me 3 more. No. 16, 17.
18.
Yeah, 18 fifths. If we were just multiplying, that's 15, but 3 more would be 18. So we've got 18 fifths minus what? What are we subtracting? 4 fifths. You've got to rewrite it. Okay? You've got to rewrite the problem underneath it with the new subtrahend is the word for it. Okay? And when we subtract, what do we get, Alex? 14 fifths. Are we going to keep that there?
No.
No, we're going to switch it back. We're going to use a number bond to do that. Okay? And so, what do we come up with?
10.
Okay. 10 of these fifths I can pull out. What does that 10 fifths turn into?
2.
A 2. Because 10 divided by 5 is 2. When I take 10 away, I've got 4 left. 2 and 4 fifths. So I'm going to put my final answer right here.
Yay.
Let me show you what started happening. I usually see this every year, and at some point I usually say something. I was looking at people's answers. I really noticed it, I guess, in second period. You see this answer right here? Sometimes in our, your working problem, you just get the answer written down. It looked like this on some people's paper.
Oh, like you said, you thought I put 6.
Be careful. It's not the same thing.
Okay.
Okay? Sometimes we make that 2 a little smaller or this a little bigger, and it starts looking like something's
Sometimes
different.
I write my 3 and it looks like a 2,
Mm-hmm.
and I get confused.
And even if the line didn't get under there,
And then I get the question wrong.
even if the line was still right there, it very much almost looks like 24 fifths. So just be careful, okay? All right. Let's try just a couple more, and then we're ready to move on.
What problem set?
Yep.
I mean, this isn't as.
It's not that bad. It really isn't. It becomes a little more to it tomorrow when we have 2 mixed numbers, but it's not terrible. It's not terrible.
Not even like just a little bit. Not even a lot. A little bit. Just not even a lot. Just a little bit. A little bit. The 5th grade a little bit harder than the.
All right, go ahead and work that one. So this probably should have taken about 2.5 seconds.
Yeah.
This did not need MAD. Boom, we're done. Okay.
That was easy.
And if this is where some of you created a lot more work for yourself without pausing and looking, okay? These are easily subtracted, so you didn't have to do math. You didn't have to do a number bond at the end. This is all you had to do was bring this over, subtract these two, you're done. Okay, so make sure you're looking closely so you save yourself some work. Okay. Now, this wasn't actually the problem I was supposed to give you, but I saw the chance to. This
I got it right.
was the actual, hold on, problem. Okay. Now
You got
that'll
it
work.
backwards.
Yeah, I did that on purpose.
No, you didn't.
All right.
Did you actually?
Here. That was the way, didn't it? Was this one as quick?
Yeah. Yeah.
Okay. Was this one as quick as the one we just did?
Oh, yeah.
No. I don't mean could you do it quickly. Was this one as quick as the one we just did? No, it wasn't. Okay. Did you need to do math on this one? Yes. Okay.
Because Ishmael don't do that thing. No, I do it on my head. If
Okay.
you do it on your head, it's faster.
When you change this into a mixed number, sorry, I always do that. When you change that into an improper fraction, what did it become? Haley, what did it become? 45 tenths. Plenty of tenths now to separate, or to subtract 7. 45 take away 7 would be, 38 tenths. Good. All right, so if you had 38 tenths, we couldn't leave it that way. We did need to do a number bond. What does that become? Reagan, what would we pull out?
3.
3 wholes, which could be 10 tenths, 10 tenths, and 10 tenths, or just 30 tenths. Okay?
And then you have 8 tenths.
8 tenths left over. So this is 3. This is 3 and 8 tenths. That's a great 4th grade answer. What's the 5th grade answer?
No.
Just ask yourself, what's the largest number that I can divide into both of those evenly? Yeah.
2/3.
Not 2/3. Keep thinking. Keep thinking.
2 tenths.
What is the largest number we can divide into both 8 and 10? 2. 2 3 4/5. Exactly. Good. Okay.
Ever since I do the fifth grade answer, I always use a brain cell.
You lose a brain cell?
Yeah.
I think you gain one, not lose one.
No, I think we lose one.
Oh, if I tell Miss Jamie that, she's gonna be worried about y'all.
Miss
Okay.
Jen, can
Yes.
I share my mistake today?
Oh, Charlotte wants to share her mistake, and yes.
Is that wrong?
Okay. No, I don't think you got it wrong after you. Okay, go ahead and share what you did.
When I was writing down the answer, I accidentally put 4 5/10 plus.
You were just writing down the problem. Yeah, before she ever started working it. She did a plus sign instead of a minus sign. How many of you have ever switched the sign accidentally? Or done the wrong operation? Yeah, look at the room.
Everybody.
We all have. Okay. But thank you for sharing that because that reminds us to be careful. This whole day is subtraction, so if that helps you today, you don't have to worry about adding today. All right, let's do one more and then we're ready to go. Okay? All right, there we go. Okay, so are we going to need to do math or can we just subtract? We are going to have to do math. Wow. Okay. 12 times 2 is what, everybody?
24.
24. Plus 2 more would be 26. 26/12 is what we have now, and now we can subtract the 7. And when you subtract, you get 19/12. Okay. Can't keep that. Gotta change it. We need that mixed number. We want to know the whole number and the fraction to go with it. Brandon, how many 12s how many 12/12s can we pull out?
1.
Yeah, because 2 12s is 24. So 12/12, and what would be our leftover piece?
Our leftover piece would be 7/12.
7/12. Okay, so we've got 1 and 7/12. And that is our 4th grade answer. What's our 5th grade answer? Yeah. 6/12 would be 1 half. Yeah.
1 and 2.
What'd you divide by?
Pretty much should just be 1.
Yeah.
Yeah.
This is the 4th and 5th grade answer here. Because you can't divide this one by the same number evenly. Okay. So sometimes you can and sometimes you can't. Okay.
That one I didn't. I did 5th grade answer then.
Yes, everybody did. If you got 1 and 7/12, you got the 5th grade and 4th grade answer.
I got 1
Okay.
and 7/6.
Yeah, that's not right. That's just writing the wrong denominator. Okay, I hope you feel pretty comfortable with this. You look like you're pretty comfortable with this. Okay. And we're going to get a little bit more practice on our problem set. When we come back, we will go through and mark the ones we're going to do. All right, go ahead and put your whiteboards away.